How is Python's list implemented? Is it a linked list? An array? I searched around and only found people guessing. My C knowledge isn't good enough to look at the source code.
It's a dynamic array. Practical proof, indexing takes, of course with extremely small differences, 0.0013 µs, the same time regardless of index. I would be astounded if I in Python or Jython used linked lists. They would ruin the performance of many widely used libraries built on the assumption that lists are dynamic arrays.
The C code is pretty simple, actually. Expanding one macro and printing some irrelevant comments, the basic structure is in listObject.h, which defines a list as PyObject_head contains a reference count and a type identifier. So, it's a vector/array that overallocates. The code for resizing such an array when it's full is in listObject.c. It doesn't actually double the array, but grows by allocating to the capacity each time, where new size is the requested size, not necessarily allocated +1 because you can extend by an arbitrary number of elements instead of appending them one by one. See also the Python FAQ.
I would suggest Laurent Luce's article Python list implementation. It was really useful for me because the author explains how the list is implemented in Python and uses excellent diagrams for this purpose. List object C structure. A list object in Python is represented by the following C structure. OB_item is a list of pointers to the list elements. Allocated is the number of slots allocated in memory. It is important to notice the difference between allocated slots and the size of the list. The size of a list is the same as lin_l. The number of allocated slots is what has been allocated in memory. Often, you will see that allocated can be greater than size. This is to avoid needing calling realloc each time a new element is appended to the list. Append an integer to the list, l.append1. What happens? We continue by adding one more element, l.append2. List_resize is called within +1 = 2, but because the allocated size is 4, there is no need to allocate more memory. Same thing happens when we add two more integers, l.append3, l.append4. The following diagram shows what we have so far. Let's insert a new integer, 5, at position 1, l.insert 1, 5 and look at what happens internally. Pop. When you pop the last element, l.pop, listpop is called. List_resize is called inside listpop, and if the new size is less than half of the allocated size, then the list is shrunk. You can observe that slot 4 still points to the integer, but the important thing is the size of the list, which is now 4. Let's pop one more element. In list_resize, size, 1 = 4 to 1 = 3 is less than half of the allocated slot, so the list is shrunk to 6 slots and the new size of the list is now 3. You can observe that slot 3 and 4 still point to some integers, but the important thing is the size of the list, which is now 3. Remove Python list object has a method to remove a specific element, l.remove5.
This is implementation dependent, but good. Python uses an array of pointers. Python uses an array list. IMPython apparently also uses an array. You can browse the source code to find out. Thus they all have a one random access.
If you want to see more, please consider subscribing.